comparing matrices. For matrices to be equal, they have to have the same values in the same cells. So these two matrices are equal to each other. 3, 3, 5, 5, 0, 0, 1, 1 in the corresponding parts. These two matrices are not equal. I have 3 in the first row, first column, but in the first row, second column, I have 5 here and 15 here. So right away, not equal. Also, this one, I don't even have to compare the cells because the size of these matrices are not equal. This is a 2 by 2, 2 rows by 2 columns. This is a 2 by 3. See, the dimensions are not equal, so these cannot be equal matrices. I can use matrices to determine values. So first off, I can see that these two matrices are equal dimensions, 2 by 2 and a 2 by 2. So I can definitely compare them. I want to determine the values of A, B, C, and D. Well, A is in the first row, first column, so A is -5. B is in the first row, second column, so B is 6. They simply map to each other. I can see that C is 0 and D is 10. It's as easy as that. Let's take a look at this one. Aha! For number 2 here, I first am going to multiply this whole matrix by a scalar. Okay, so I multiply it to everything inside. So I usually go like this and make my spots so I don't forget something. 3 times -5 is -15. 3 times 6 is 18. 3 times 0 is 0. 3 times 10 is 30. So now A is -15. First row, first column. B is in the first row, second column. So B is 18. C is in the second row, first column, as is the 0. And my D is 30, same place, okay? And you don't need to name the places to match them up. It's just like mapping. Okay, here we have number 3, and this time I want to do a little teeny bit of algebra. So I'm going to use my mapping. So I have -5 is equal to 5A because they're in the same place. I want to solve for A, which means get it alone, divide off the 5. So I get -1 is A. I'm going to do the same with every one. Now I have 6 is equal to 2B. I want to solve for B, which means get it alone. The 2 is attached by multiplication. So I'll move it by division to the other side of the equal sign. I'm getting 3 equals B. I'm going to go up here because I'm running out of room. Now I have 0 equals 17C because 0 maps to this part. I want to get C alone. 17 is attached by multiplication. I'll move it by division to the other side of the equal sign. I'm getting 0 equals C. And finally, I have 5 equals D. The D is already alone, so this is done. So now I've solved for these. I want to use my matrices again, which is really just a nice way to organize data in some respects. And I want to solve for X. So I see my X is right here, and it's going to be equal to 2A. So I have 2A equals X. But I don't know the value of A. So I see A is also in row 1, column 1. So it must be equal to row 1, column 1 over here. So I have 9 is equal to 3A. Now I can solve for A. I want to get A alone. 3 is attached by multiplication. Move it by division, its partner, to the other side of the equal sign. So I'm getting A is 3. Now I can go to what was my goal, and everywhere I see A, I can put 3. So I'm getting 2 times 3 is 6. 6 equals X. All done. Example 5, determine Q. So I see Q is a scalar on the outside here, which means I'll have to multiply it through to everything inside. But I want to make my life kind of fast here. So I'm only going to do what I need to do. So I'm going to get 12 equals 36Q. See, the Q would go to every single cell inside this matrix. But I don't want to be distracted by the A and the X and the Y because I only want the Q. So I have 12 equals 36Q, get the Q alone. 36 is attached by multiplication. move it by division to the other side of the equal sign. 36 is the same as 12 times 3. 12 over 12 reduced to 1. So I have 1/3 equals Q. All done. Number 6, determine A plus B. Okay, so I see B is in here. A is a scalar on the outside. I am going to multiply this through. Negative 5A is the first row, first column. 6A, first row, second column. 0 times A is 0. And 5 times A is 5A. And this is equal to this whole thing. Okay, I now know that, well, 2B is equal to 6A. So I can write that out here because I think maybe I'll use it. And then I have 15 is equal to negative 5A. Ooh, I can get that. Negative 5A equals 15. I want to get A alone, divide off that negative 5. And I'm getting A equals negative 3. So that makes me happy. I can go right up here, and everywhere I see A, I'm going to put negative 3. There's Trudy in the background. So I'm going to come down here because I don't have a lot of room. So I have 2B equals negative 18. I want to get B alone. 2 is attached by multiplication. Move it by division to the other side of the equal sign. I'm getting B is negative 9. Now I have my 2 pieces of data, and now I can go right here. And my goal is A plus B is, let's see, A is negative 3 plus, negative 9 equals negative 3 plus negative 9 is negative 12. All done. Thanks for being here.